Hi, everyone, and welcome to the sixth webinar in our virtual classroom series. In our previous sessions, which are all available on demand for free, we've discussed our release strategy and patching process, upgrading with auto upgrade, performance stability, and various types of database migration, including cross-platform migration and migration to multi-tenant. But we have one more migration topic for you, migration to cloud.
One could ask, isn't a migration to the cloud like any other migration? And it's kind of true. You could say it's the same, but different. For instance, when you go to the cloud, you have other tools in your toolbox.
Hey, Daniel, don't forget, in the cloud, you are migrating into database services. And some of those you won't find on regular on-prem, such as the autonomous database. In addition, some of them have restrictions, others offer additional functionality. So we will guide you today through all the best technologies so you can choose the best method for your migration into the cloud.
Allow me to introduce Roy Swanger. He is our Vice President for Database Upgrade, Migrations, and Patching, which means that he also covers Data Pump, SQL Loader, and Data Patch. Roy has a long career in Oracle behind him, and he has a very strong technical background. So even though he has moved up the ranks at Oracle, he still enjoys to get his hands dirty while he types in the terminal.
And this is Daniel Overby Hansen. Daniel works out of Copenhagen, Denmark, and he's our Senior Principal Product Manager for Cloud Migrations. But when you visit Daniel's blog on dohdatabase.com, or you follow already Daniel on Twitter with DOH Database, then you realized Daniel does much more than just cloud migrations. He covers the entire upgrade topic, mainly with auto upgrade, but also some special technologies such as TDE in relation to upgrades and migrations.
And this, of course, is Mike Dietrich. He's based out of Munich, Germany, and he's our distinguished product manager for database upgrades and migrations. Mike runs the phenomenally popular Database Upgrade blog, where you can find the slides for this session, links to our videos, and of course, a wealth of technical content posted regularly once or twice a week. You can also follow Mike on Twitter.
So before we can start, there are a few organizational things up front, as usual. You can download the slides already from the Upgrade blog. So please go to mikedietrich.com/slides and then to Webinar 2021, and you will get access to the slides while I'm talking here. Next topic, this seminar will be recorded, and we will make the recording accessible in a few days. Go to the Upgrade blog again, to mikedietrich.com/videos, and find the video there in a few days. As soon as you see the new red tag for Seminar 6, then this is the recording for today's session. Feel free to share it with your team members, your colleagues, and everybody who is interested in migrations to the cloud. Then, very important, please, your questions go into the Q&A, not into the chat window. Please be disciplined and put it into the Q&A. Makes your life easier, our life easier as well. And in case you would like to preserve the questions and answers afterwards, we will stay at the end of the seminar for 8 minutes in the seminar, so you have enough time to do a copy-paste of the entire Q&A window. In case you have sort of connection or resolution issues, because we are broadcasting in HD, please disconnect from the Zoom session and connect again. And this seminar will run roughly 2 hours. After 1 hour, we will do a 5-minute break. And then the seminar is not over. I promise we'll go on after the 5-minute break with the next topics. So now it's time to enjoy, and let's go forward with today's topics.
It won't be a surprise to anybody who's heard Oracle talk about cloud that the first subject that we'll get into is Oracle Autonomous Database. It's worth understanding what Autonomous Database is so that you can then understand how it will affect your migration strategies and options. So first of all, let's think about Autonomous Database in the large. Just as developers no longer work in machine code and assembly language, but they tend to work at a higher level of abstraction. The point behind Autonomous Database is to allow DBAs to work at a higher level of abstraction and relieve you of the routine maintenance work that you might otherwise have to perform. The reason for this is very simple. DBAs now are tasked with managing 10 to 50 times as many databases as they were even just a decade ago. I know some DBAs that manage more than 200 databases as an individual. And if you're paying attention to things like backups and updates and patching and all of that stuff on a daily basis, it's going to utterly consume you and not allow you to pay attention to things like application performance. So just as you no longer have to manage free lists in your database, we're trying to, with Autonomous Database, relieve you of those other mundane tasks to allow you to free yourself up for more important work. If you get into Autonomous Database, the first distinction you're going to find is in the infrastructure. We have what we call shared infrastructure and dedicated infrastructure. Shared infrastructure is, pretty simply put, you get a PDB on a container database in our cloud somewhere. You don't control where it is. You don't control who else is in the same container database. It's a very simple choice. We'll show you how simple in a minute. It's also very elastic. You can auto scale to meet higher processing needs, higher storage needs. But Oracle will be in charge of all of the routine maintenance there, your patch and your upgrade, and all of those other things that go into your database lifecycle. Dedicated infrastructure gives you a bit more control, a bit more isolation and therefore security, but it then also imposes on you a bit more work because that means that you have to control the things like the policies of how lifecycle management operations will take place or when they might happen, workload optimization, and so on. So you have those two choices of shared and dedicated. But there's one other point I want to make about shared versus dedicated. With shared infrastructure, you can have, say, a one OCPU small database. You can just throw it up there on shared infrastructure and away you go. But with dedicated infrastructure, because you get dedicated hardware, you do have a minimum usage to which you need to subscribe in order to have that dedicated infrastructure. So if you just want to use Autonomous Database on a ad hoc basis for a database now and again, shared infrastructure is probably your better choice. For dedicated, you really want to have a plan for how you're going to use that hardware. Now, there are restrictions in Autonomous Database. In order to have the machine learning-based tuning and optimization and the automatic operation of these databases, there are some areas where we've put restrictions in place. For example, parameters. Especially in a shared environment, there are going to be some parameters that you cannot modify on a PDB by PDB basis. There may be some SQL commands that are not available because, for example, one of the users that you get is the admin user. You don't get access to system or sys in that autonomous environment. So the admin user is very highly privileged, but not full DBA privileges. So there are going to be some SQL commands that are locked down, especially anything that could affect someone else using the same infrastructure. Certain data types are no longer supported as we move into our cloud environments. For example, we really don't want you using long and long raw in the cloud. Those have been deprecated for well over a decade now. It's time to start moving off of those. So we want you to use more modern data types that are much easier to manage on an autonomous basis. And then there are some features that are not available or perhaps not yet available. And that's a key point. When I say not yet available, these cloud services do tend to evolve very quickly. We come out with monthly updates on our shared infrastructure and at least quarterly on dedicated. So you may find some of these restrictions being relaxed as we go forward. I'll give you an example of that. When we first came out with autonomous shared infrastructure, we did not allow partitions or indexes at all in that environment. We now allow them, but we recommend that you let us create the partitions and indexes as needed, but we have relaxed that restriction over time. It's just one example, and that's why the pro tip here refers you to the documentation to get the latest on the service that you're going to be using. Another cool aspect of Autonomous Database is that we have the always free tier. And when we say always free, it's free of charge for up to 2 databases. And there are different mixes of databases you can have. It can be on Autonomous Database, there are NoSQL databases, and so on. So again, look at the documentation for the latest offerings that are available. And when we say always free, we mean always free. Now, in order to do that, of course, we are limited in the amount of disk space that you can use, the processor shapes, and so on. But it's a really nice way to dip your feet into the Autonomous Database world and understand it without incurring any cost or worrying about whether some sort of free trial is going to expire. So I really encourage you to take a look at that always free tier. So here's a little demonstration of creating an autonomous database. We're going to start with the ADW service, which is Autonomous Data Warehouse, but you'll see you can even change your mind as we get into this. We'll give it a display name and a database name that mean something to us. We'll select the data warehouse service on shared infrastructure. We'll give it a few more OCPUs here in this case, where that means it's a paid service. Give it a password that we're going to be able to remember. And of course, that has to match. And then we'll take a bit of other housekeeping, like what kind of network do we have? In this case, we want public IP access, and we're bringing our own license. You then get this page, which will take less than a minute generally to provision this database. And this shows you, for example, that multi-tenant is one of the underpinnings of the Autonomous Database service. That's how we can provision things so quickly, how we can move them around for load balancing purposes when needed, how we can do our patching so quickly, and so on. Now, if you want to connect to this database, you will download this credential wallet. This wallet is kind of related to the security wallet, but it has other information there too, like your SQLnet connection files and so on. It's a zip file of those files that you need to connect from the client on your on-premises system up into the cloud. So once you have that zip file, you put it in your local area, and then you'll be able to connect to your autonomous instance. So as you can see, you can get to Autonomous Database start to finish in probably less than 5 minutes to create that database, download the wallet, and be ready to connect. Now, when you're going to migrate to that database, I mean, connecting to an empty database is all well and good, but really what you want to do is migrate to it and have data up there. One thing that you really need to know is that migrating to Autonomous Database is migrating your data, not your database. Because we've provisioned a pluggable database there, what you're going to do is migrate data into that pluggable database. You won't be physically moving your on-premises system up into our autonomous infrastructure. How do you do that? Well, there are a couple of options here. You have the direct option, which would go over DB links. You have the staged option where you go by object storage. And at this point, what I'll do is I'll turn you over to Mike to talk about how exactly you would take those options and migrate into the Autonomous Database.
No fear. There's a reason that I choose that background here. This is where metal all started more than 50 years ago in Birmingham. And we would like to import a deaf metal data set. But we don't want to discuss metal. We would like to show you the different approaches, how to import the same data set over and over again. So first approach will be using the SQL Developer Web here. And the SQL Developer Web is easily accessible from the OCI console, so you don't have to install anything. It's quick, simple, straightforward, and it works with your CSV, XML, JSON, Afro files, and the best thing, even with your Excel sheets. So we would like to show you that. And therefore, we go to the OCI console. And on the OCI console, under Tools, you find the SQL Developer Web. It's already there. So no installation needed. And it has this tab here for data loading. And what we do is we take one of the free CSV files we will load. Here we take the album CSV and drag and drop it into here. The first set of data is already read. Delimiters here. Now I may adjust a few data types because the ID and the band ID here is a number. And then I load my data. This is the DL code. So you see, this is the table which gets created now from it. I don't have to pre-create it. The mapping and data is there. Now, let us check if there are really 28,000 and a bit of rows. So we go to the worksheet and select star from albums. And here they are. So we can scroll through them. That was super simple and straightforward and no installation required. Next will be SQL Developer. And I have to confess, this is one of my personal favorites here. So it has a local installation, okay, but I use the SQL Developer for all types of admin tasks. So it's already there in my environments. It's also quick and simple, and it works also with the same type of files as the SQL Developer Web. And again, we would like to show you a demo. And here in this demo, we use the installation, and I downloaded the wallet metal here, which I downloaded from my ADW console. Now I create a connection with my admin user, I save the password, but the magic is that this wallet file I choose here in the SQL Developer. So I browse to that file, and the SQL Developer automatically reads now all the connection options. So I have metal, high, low, and medium. I choose medium here by accident. High would be better for data loading. So the connection is there, I saved it, and I import data. This is the option here in SQL Developer. So what I do is I choose my local file. I start here now with the bands CSV. So it reads already the first 100 rows. The table it will create needs a name, so I choose obviously bands. The mapping of the columns, I want all my columns here. And I will do a little bit of cosmetics now to some of the columns with the data types. I think to remember that the newer versions of SQL Developer are a bit more intelligent, I would say, and read more data to find the best values for you. So less cosmetics needed. So you see, I adjust the lengths and then I finish. Now it loads the rows from my CSV files into my autonomous. That is very simple and straightforward, and by far no rocket science. Everybody can do that. Second table, and you may ask yourself, why are you showing me the next table? Just for completeness, we fast forward this, the albums table. A little bit of cosmetics again, and bang, we load the albums, and that's it. Because with the third CSV file, the reviews, we would like to show you some special feature in Autonomous. So these are the reviews for all these albums. So I give the table name reviews, makes sense. And we fast forward again the cosmetics part until we come to a certain point. Because when we check the content in a second, so score, the content, you see, it recognized automatically that it's longer than a varchar 24000. And it chose the maximum length on that file because max string size is extended already. I go higher with 24,000, just for the case that we have more and longer reviews later on. But this is also very cool in Autonomous, that you don't have to care about the length of a varchar in your source file. Very convenient, very simple. Takes you 5 minutes and your data is there. And this is pretty neat. But what if you would like to automate that? And for automation, the SQL Loader is the perfect tool. And as you may remember from the previous part Roy presented, with the SQL Loader, we can also go around the object storage. So we don't need that. And even though the SQL Loader sounds very, very old-fashioned because it's out there for ages, it's highly configurable, it can transform even data, and it loads from a local file. It works with CSV and text. So the idea is we have a CSV file, comma-separated file, and then we define with the loader a load file, and we automatically load that. It could be quality data or whatever you have on your local system, and you load it over and over again, maybe with a cron job. So let's sneak into that as well, and let's load our data again. So here you see the structure of the album CSV. So we have an ID of the album, the band ID, and the album's name and the year. Now I connect with my SQL CLI. I create a table. In this case, I need to create it. So I create the albums table. And here's my load file. So I connect with Metal High table. I load into his albums. This is the file I load. And there's not much more needed. And bang, it kicks off. And this is real-time recorded. So it's super, super fast, 28,000 rows loaded within a few seconds. And let's check the log file if everything went fine. So this is 28,069 rows successfully loaded, no errors. That's cool. That's fast. That's easy. Let's do a check. Connect again to my autonomous instance and select star the first 10 rows. So data is there. Very easy, very straightforward. And especially when you have to write a job doing this over and over again, that makes a lot of sense. So pretty cool. And then Daniel is on with the next technique, data pump. Daniel, your turn now. Thank you.
Thanks, Mike. Next up, data pump. Oh, good old data pump. If you have a lot of data that you need to move into the cloud, data pump is really a good fit. When you use data pump, it's really fast to export the data and then do the import. Another benefit of data pump is that you can work on the entire data set or only a subset. And you get all the flexibility of data pump, so you can even transform your metadata into something that fits very well in your autonomous database. Something that you should be aware of when you use data pump. When you go into the autonomous database, there is a limitation on how many parallel processes that data pump can spawn in one job. And the default is 50, and currently there is no way that you can change it in the autonomous database. So you should be aware that for really big data sets, you will have a limitation of 50 parallel processes when you do the import. That was the basics. Let's see how it works. First, I'm in the OCI console, and I'm generating an authentication token that I can use when I need to connect to the cloud. Instead of using my password, I can use this authentication token. You can see here in the documentation how you can use the DBMS cloud package to create a credential that uses your authentication token. So I'm preparing a script where I'm specifying my username and my authentication token and connect that to a set of credentials that I can use later on. I have here the wallet that I've downloaded, and I set my TNS admin to the directory that holds the wallet. You can see here in tnsnames.aura that I have connection descriptors to the various services. I then connect to the autonomous database as my admin user, and I'm using here the Medium service. Now I'm starting my SQL script. Remember, this was the script that created my credential that I can use to connect to OCI, to the object storage. Then I switch to the OCI console and I create a separate bucket called Metal POUG that I can use for this demo. And here, because I have a fairly small DOM file, I'm just going to upload it directly using the web interface. If you have a really huge DOM file, you would probably use OCI, CLI to do the upload. But for such a small file, it's easier to just use the web page. Oops, there it is. Now I look at the details, and I have here a URL that points directly to my DOM file in the object storage. I copy it, and I put it into my DataPump parameter file, so DataPump knows how to get hold of this specific DOM file. Then I simply just start the DataPump client. I give it my PAR file, and then it'll start to load data into the autonomous database from the bucket in the object storage. So you can still use the full power and the full flexibility of DataPump when you need to move your data into the autonomous database. Next up is DBMS Cloud. DBMS Cloud is a PL/SQL package that you can find in the cloud database. This is really good because it can load data from various kinds of object storage, not only OCI, but also those of Amazon and Microsoft. In addition to that, it can work on a number of different file formats, from the simple CSV files to DataPump DOM files, or it can even read zipped files. If this is something that could be of interest to you, I would highly recommend that you visit the Quick Start lab that you can find a link to here in the bottom of the slide. A quick tip when you have to use DBMS Cloud is to use SQL Developer or SQL Developer Web. Then you get a nice interface to use the PL/SQL package. It's coming soon to on-prem. It's not only a cloud feature anymore. And for your reference, I've included here links as well to troubleshooting and documentation. But enough talking. Let's see how we can actually load data into the autonomous database. Here, I'm connected to the autonomous database using SQL Developer Web. First, I start by creating a table into which I can load my data. Then I create a set of credentials that connects to my user in OCI, and I'm using the authentication token, not the password. Now I can use the DBMS Cloud package to load data into my albums table. I'm using the credentials and the URL to my CSV files and just some formatting options. And that's really all it takes to load a CSV file into a table. Now I can simply do a select table on albums, and I can here see all the data that was in my CSV file. So DBMS Cloud is a very simple interface that you can use to load data into the autonomous database. And one of the things that I like about DBMS Cloud is that you can use tools that you can find entirely in the OCI console. SQL Developer Web, object storage bucket, load the data, and then use DBMS Cloud. It's simple. The last option is Move to ADB. Move to ADB uses DataPump in schema mode. It's a one-button approach that does a lot of automation and make it a lot easier for you to move your data into the autonomous database. But in fact, it just uses DataPump under the hood, so it doesn't do anything that you yourself couldn't script. But we just made the hard work for you. You have now a simple interface with Move to ADB. You can use it to load data from other Oracle databases using DataPump into the autonomous database. Some good recommendations when you use Move to ADB. First, you should always enable DataPump metrics. A little later today, we will cover why this is important, but when you use Move to ADB, you should know that you can simply add the switch DB debug and it'll do the work for you. In addition to that, I recommend that you exclude statistics from your export and then regather statistics in the autonomous database. Things are a little different in the autonomous database, and it's a super fast and super powerful platform. So it's probably a lot easier and a lot quicker for you to just regather new statistics in the autonomous database after you've loaded all your data. And finally, if you have license for compression, I would recommend that you put compression on the DataPump DOM file. It can really reduce the size of the DOM file, which makes it a lot faster to upload to OCI. Let's see how you can use Move to ADB. I have here a simple text file, a configuration file for Move to ADB. It contains information about the database, my source database, also information about the autonomous database, and finally some credentials for OCI and information about the bucket that I'll use for a staging area. Then I simply call Move to ADB. I specify my configuration file and I start it in auto mode. This is our one-button approach. It starts out by doing some validation. Then it starts data pump. You can see the command line here, and it does the export. And there we have the tables, all the rows. We have now created dump files. Let's upload them to OCI. There it is. We're creating a credential in the autonomous database. Start data pump to load from the object storage directly into the autonomous database. You can again here see the command line. And while I talked, the import completed. Now let's recompile the schema to ensure that there are no invalid objects. That's done. So let's see that my data is there. I connect as admin. And I do a select star from metal.albums. I'm just fetching the first 10 rows. And there you have it. There are my metal albums. So as you can see, I could load data from one Oracle database into the autonomous database. Very simple with Move to ADB. For your reference, we've included here an overview, a matrix that lists all the options that we used to load data into the autonomous database, and some information about some of the features that you can use with the tools.
Now, thanks, Daniel. But there are even more options. For instance, we could use insert via REST API. As Jeff Smith showed in his blog post, how he loaded 10 million rows in less than half a minute via the REST API. We could use SQL Developer Database Copy, quite a cool new feature, or very old-fashioned techniques such as over database links, create table as select, or insert append select statements. All that would work. But if you have a lot of data, then let's be honest, data pump is the only option then. So please follow our recommendations and best practices. And if you want zero downtime or near zero downtime, then there's no way around GoldenGate. So while I say that, I can see some of you already thinking, oh, wait a bit, that's too complex. And some others saying, oh, wait, there's a huge price tag associated with it, right? And some say even both is true. And no, not in that case. So a quick recap what GoldenGate is doing. First of all, we need an initial copy. And then we need a process which captures our statements, our inserts, our updates, our deletes. Then this will be sent over to our destination site in the cloud here, and then replicated or replayed. So in GoldenGate terminology, it would be replicate. And that is the idea. Now, GoldenGate is now a cloud-native service, and it runs with GoldenGate 21c, managed by Oracle. So this is the good part. At first, you don't have to manage and set up all this. It's already there. And it auto-scales. It has a very attractive price tag because, as you will see in the demo, you can run this with just one CPU. And you pay by the minute you use it, and the price is very low, actually. It supports as a source 11.204 and anything higher. So it works with DBCS, XRCS, autonomous transaction processing, and autonomous data warehouse. So this is really, really cool. I would like to show you that in a quick demo, because then you see, hey, wait a bit. I have two databases, one on-prem, one in the cloud. I can easily sync them with GoldenGate. And it's no rocket science anymore. So we start here. We check out, go a bit down here to GoldenGate. And I need a deployment. So I'm not deploying a database. I'm deploying my GoldenGate service now. So I call it GG for migration. It's in our compartment. And you see I use just one CPU here. And I bring my own license, or to include a license, we bring our own licenses here in our demos. Then we need a user and a password, of course, and we will use that to log in later on to that service. So it takes a little bit, and then this GoldenGate service will be provisioned, and here it is. Now I can start launching my console. Here's the address. I copy paste that address and put it into my browser. When I access this address, I get the login prompt here. So I put in the GoldenGate user I created before for migration, GG for migration. And here it is. So what could I do now? I can now access my source and my cloud database from that and just tell it, hey, replicate, please. Just with one OCPU. And this works smooth and flawless. And the cool thing is in that console, we don't show you that here. You get also all the cool graphs. It shows you exactly any lags or how much data gets replicated. And this is a very cool and convenient way. I like this a lot because it took away the complexity of all the setup tasks. And it's really very attractive. Another thing here we want to quickly and briefly discuss is a new kid on the block, the Autonomous JSON database. And the Autonomous JSON database is a cloud document database service. It makes it simple to develop JSON-centric application, features simple document APIs, serverless scaling, high performance, ACID transactions, comprehensive security, of course, and low pay-per-use pricing. So what are we doing? We need a JSON database provisioned. And in this case, we do it here on the command line, intentionally to show you that this works as well. So on the command line here, OCI DB Autonomous Database create with the workload AJD, and I give it a name, metal JSON. Yeah, we are still dealing with our metal tables here. Now with this request, I can check with the work request, I can check how far we are. So we are here in progress. It's not fully provisioned yet. So I send this request later on and I get succeeded. So it is provisioned. Just to show you that you can do this also outside the console. So here it is. I have now a JSON database in Autonomous. Now let us load data into our JSON Autonomous database. And first attempt will be using the SQL CL. And here we use Soda, which is natively in SQL CL. So what do we do first? We have now the information not in a CSV, but in a JSON file, the albums here. And we will open the door with the wallet and connect to our admin user in the JSON Autonomous database. So we are in. At first, with a Soda call, we create a collection. And in this collection, we can then store the JSON documents. So next call is then insert albums, and this will store the documents. The good thing is, as we have, it's an Oracle database, a converged database, we can read the data now with simple SQL, and this is the result. So the data is in JSON stored, but we can read it with SQL calls. And another option would be the REST API. So this is also fast and easy, and it's using the Oracle REST data services. Jeff Smith is our product manager, and on Jeff's blog, you will find a lot of examples and good information how to use the REST API. So we do the same example here, but now using the REST calls. So the same file, albums.json, you saw that before here. This is the structure. And in this case, with curl, we do now a put, which creates the collection via the REST call. And the collections is albums. And then I do a curl post call, and this will now store the information in this albums collection. So here, this is the file albums.json, and it will store it in this collection albums. And again, with a very straightforward SQL call, once I connected here using my wallet file to my instance, specifying the password. And with that simple SQL call, I can query the data in that JSON database as well. It's time for Daniel now to do a deep dive.
Thanks, Mike. That was some really interesting and fancy JSON stuff you got there. But now I'm going to change the context and we'll do a deep dive into migration to autonomous database. First, I would like to talk about the Cloud Pre-Migration Advisor tool. This is a new lightweight utility that we just launched, which can do an analysis of your on-prem database, look at the schemas, and perform a deep analysis about the consequences of moving your data into the autonomous databases. For instance, it can give you recommendations or warnings if you have objects in your sys and system schema. Or imagine that you are using Pump&GoldenGate to migrate your data into the autonomous database. If there are some things in your schema that you should be aware of, it can come up with very specific recommendations that'll help and ease your migration to the cloud. The tool is strictly non-intrusive. You can run it on your on-prem source database. Don't worry, it won't change anything. It can even run in a read-only database, so you can run it on your physical standby, for instance. You decide whether you want the output in a text format, in a text report that a human can read, or you could also get it in a JSON format, which are for those few geeks that know how to read JSON, or if you have some sort of automation engine, Ansible playbook that you want to add this to, then you can use the JSON format. When you have data on-prem that you need to move to the cloud, we should talk about how you can get them there as best as possible. You should use what is called multi-part uploads, and it's part of the OCI command line interface. It is recommended for files that are larger than 100 megabyte, and it works by splitting the file up into chunks and then individually in parallel upload those chunks to the cloud and then put them back together to one big file. If you have many files to upload, you should use bulk uploads. Instead of working on a single file, it'll scan a complete directory and upload all the files. Underneath the hood, bulk uploads also uses multi-part uploads. So with bulk uploads, you get the best of both worlds. You can upload many files, split them up into proper chunks, and upload them in parallel. If you want, you can optionally fine-tune the number of files to upload in parallel and the chunk size. But if you don't do it, it'll automatically split at 128 megabyte and do 10 parallel uploads at the same time. By using chunks and parallel upload, you can ensure that you can max out your bandwidth to the cloud. In addition to that, if you want, you can prefix the files as they arrive in the cloud in the object storage bucket. You can give them a specific prefix, which will make it easier to identify those files when you look at them in the cloud. And you can selectively either include or exclude files from your directory. So if you have a lot of files in your directory, you can upload them all, except only for a few ones if you want. Once the files have arrived in the cloud, it is time to verify that we didn't get any in-flight corruption on the files. The files that you send to the cloud has to travel a long way through a lot of routers, firewalls, and so forth. So from time to time, we do see that in-flight corruptions sneak in. A good way to ensure that you didn't get any corruption is to do a checksum of the file. So you take the files on your on-prem system and you calculate an MD5 checksum. When you have that, you can compare that to the checksums that you can get from the DBMS cloud package. And if the checksums are the same on the two files, you've ensured that no in-flight corruption has snuck in. Now that your files have arrived in the cloud, let's look at how you can get those files into the autonomous database. When you need to load the data in there, I would recommend that you scale up on resources to ensure that the migration can happen as fast as possible. When you scale up on CPUs, it's online on an autonomous database. You also scale up on I/O. So by adding a lot of CPUs during the migration, you can ensure that we can load the data as fast as possible. In addition to that, you should always connect to the high service. Remember that when you download the wallet, there are 3 connect descriptors to the database. If you connect to the one that has high as a suffix, you will ensure that the resource manager allocates as much resources to your session as possible. And also, you should look at the table spaces. In an autonomous database, you get one table space called data. It's a big file table space, which, as any other big file table space, has a limit of 32 terabytes. Now you might ask, but Daniel, what if I have 50 terabytes of data to load? Well, don't worry, then you will get a data 2 big file table space and data 3, data 4, and so forth. So you can load much more data into an autonomous database, even though that the table spaces are big file. What you should take care of before you start to load data is that you have extended the data file to somewhere around where you want it to end. If you need to load in 10 terabytes of data, I would recommend that you that you extend the data file in advance. If you don't do it, the database will extend the data file as it progresses, but that will increase the risk of concurrency issues if multiple sessions need to fight over which one has to do the extension. And plus, it takes time to extend that data file. And since this is something that you can just do in advance, I would recommend that you do it. Now that we've covered some recommendations, I will leave it to Roy to take you over some more data pump related recommendations.
Thanks, Daniel. That is a really good foundation for getting ready for your autonomous database migration. Now I'll take you through the use of Data Pump for that migration, because as you heard earlier, migrating to the cloud might have a few little tweaks and tricks that you want to apply, which are different than migrating on premises. This first recommendation, for example, well, that's the same as we would do on premises. Don't use SysDBA. And part of the motivation is the same as well. There are different performance and behavioral characteristics for SysDBA versus a normal user. But the other reason we say this is that in the cloud, you'll be migrating using the admin user for the import. And the admin user is very privileged, but it is not a fully privileged account like sys or system. So you can't even specify admin as SysDBA. This means that if you don't export with SysDBA, your dump files won't have a bunch of stuff in them that admin can't import anyway, and it'll make the log files that much cleaner. Speaking of cleaner, another way to organize information is to use that parameter file instead of a long command line. This is a very simple parameter file that you see here, and it doesn't even have many of the options that we would specify for a cloud migration. So you can see why this would create a very, very long command line in your terminal window, which would be harder to read, more likely to be mistyped. If you put it into a file, it's organizing your thoughts, and it's often reusable for other migrations, and even mostly reusable on the import side as well. When you're exporting, it's a really good idea to export to multiple dump files. That's generally true anyway, because you want to take advantage of parallelism unless you're using standard edition. So using multiple dump files is a good idea across the board with parallel. But when you're going to the cloud, it's even more important to combine multiple dump files with a file size limit, because you're going to have to migrate those files up to the object store. And if you have multiple dump files that are in kind of digestible chunks, you can copy them up in parallel. And if the network gremlins creep in and corrupt any of those files during that copy, recopying a 5 gigabyte file is going to be a lot easier than one big 500 gigabyte file for a database. So the file size parameter is there for export. The dump file parameter would be for import as well. We recommend migrating using schema mode instead of full migration mode. The reason for that is that you've already deployed that new database, that pluggable database in Autonomous Database. And what you should really be doing is migrating the data or the particular application schemas, not the entire database. That's why we have the admin user there. It can handle your application schemas, your user schemas, but it's not going to be bringing in things like your AWR reports and other things that might come from a full database export. We want you to exclude statistics on both export and import. Excluding them on export, of course, means that you don't have to exclude them on import, but sometimes you end up as a DBA importing a dump file that somebody else has produced. So good idea to exclude statistics on import as well. The reason we want to exclude statistics is it just makes the operation faster, and because the stats that are gathered in Autonomous may be very different from what you had on premises anyway. The data may be laid out differently. You may be excluding indexes, partitions, and other things that affect the statistics. So just leave the statistics at home, bring your data, and we'll make sure it runs properly. Diagnostics are always important for Data Pump. As you see here, log time equals all, metrics equals yes. That's what we want you to use on every migration, especially log time for performance and metrics for individual looks at objects and parallelism. For example, if you have no diagnostics, you see that in the top box here, we're just getting that typical list of what was imported, but we don't know how long each object took. We don't even know if parallelism was in use here. With all the diagnostics, we can see down to the microsecond how long each individual object took, and we can see that there are 3 workers going in parallel and what worker is handling which object. That can be really useful if, for example, a worker is stuck on something, you can see what it is stuck on, and if we have to kill that worker process, restart it, we'll know what we'll have to restart on. Generally, when you're migrating a database, you want a consistent export. Unless you're going to be migrating in conjunction with GoldenGate, use the flashback time or flashback SCN parameter to get that consistent export. That is an export side parameter only because on import, everything will be in the dump file as of a particular point in time anyway. Use parallelism wherever possible. Of course, that's only an Enterprise Edition option, but parallelism just makes everything go faster. We generally guide you to use number of OCPUs on OCI. On premises, use the number of physical cores times 2, which is CPU underscore count in terms of Oracle parameters. When you're migrating to the cloud, if you have columnar encryption implemented on premises, you should remove that before you go to the cloud. The reason for that is that in cloud, we use tablespace encryption, and you cannot combine columnar encryption and tablespace encryption in the same database. We implemented a transform in Data Pump just for this reason, where you can omit the encryption clause on export, and then when you import, you will take on the encryption that is implemented in the tablespace in the cloud. To speed up your migration, use compression if possible. Compression is always a performance win for Data Pump anyway, because it basically trades off CPU increase for a vast decrease in the amount of I/O. And generally, CPU is a lot faster than I/O. But when you're migrating to the cloud, we also get the benefit of just having to move less data. Your files will be smaller as you're copying them over the internet up into the object store. So our general recommendation is to use compression equals all with a compression algorithm set to medium. Now remember, this does require the advanced compression option if you're doing this yourself. So you might want to be aware of whether you're licensed for that. Or, as we'll talk about later, use ZDM, which will perform compression for you and incorporates all of that technology for free. Here's an example of compression numbers that I ran on a eBusiness Suite database, and you can see that medium gives you a very good compression ratio combined with a very good runtime. It's generally going to be faster, sometimes much faster than using high compression, and even much faster than using low compression. Now, a few other tweaks that you might want to think about when you're migrating to the cloud. The views as tables parameter can be used to export a subset of data. You could define a view over a much larger table. So let's say you wanted to migrate parts of a facts table and just play around with Autonomous Database to get used to it. But you don't want to take your 100 billion row table up into that new instance. Well, you could define a view over that table, which selected only, say, 1 million rows of the table, export that view as if it were a table, using views as tables. And then when we import, you would have a million row table for your autonomous database. So it's a nice way to move just subsets of data without having to apply a query parameter at the data pump command line. When you're importing from the object store, one of the newer features we implemented in Data Pump is to be able to use wildcards even for object store file names. So it applies not just to directory and file name on your file system on premises, but now it applies to object stores as well, as you can see here with the %u. And that makes your command lines or your parameter files so much shorter when you can wildcard like that. One of the things that we want you to do when migrating to Autonomous Database is convert index organized tables. That's what IoT is here, not Internet of Things, index organized tables to heap tables. And we implemented a transform in Data Pump to do that. You can see it here. It's got a kind of not easy to pronounce name, but use this transform and it will automatically convert your index organized tables to heap tables, with the exception of certain tables like advanced queue tables that have to remain in IoT format. We have another transform that is there specifically for constraints to make sure that we use the right name for primary and foreign key indexes. Constraints, primary key constraints are implemented as a unique index. So having that correct naming there is important when you're migrating into autonomous, and you should be using the constraint use default index transform if you have primary and foreign key constraints. We also want you to not bring your segment and storage characteristics up to autonomous. So you don't get to define that in an autonomous environment. In general, you don't get to tell us where to put files or what the other characteristics of the storage are. We figure that out because we know what's underneath in the Exadata hardware stack. So by saying segment attributes no, you let us place the data in the most optimal way. Especially for autonomous database shared infrastructure, you'll only get the data table space. So you have one and only one table space, big file table space there, and it's enhanced so that we can have more than 32 terabytes up there, even in that one table space. In order to get your data there, you would want to remap table space into data for all of your table spaces. So no matter how many other table spaces you have, use the remap table space parameter, use the % to wildcard it, and you remap all of your table spaces to data. Now, this is not strictly required on dedicated infrastructure where you do have the ability to create a handful of table spaces, but it's still a good idea to minimize the number of table spaces in autonomous database. And even on dedicated infrastructure, it wouldn't be a bad idea to remap everything into the data table space. Now, some other best practices here. Excluding these object types, indexes, clusters, materialized view related things, is a good idea on your export, or if you don't have control over the export, do it on the import. The reason is that we want to manage these ourselves. Originally, an autonomous database shared, we didn't even allow you to bring in materialized views or indexes. We now allow it, but we still prefer to define those ourselves. We have autonomous indexing up in autonomous database, for example, that will put in indexes when needed for the workload. The other thing that you see here is on the export side, specifying data options equals group partition table data. So what we want to do is for partition tables, we want to export them as if they were not partitioned. Because again, in autonomous database, we prefer that Oracle be the ones defining the partitions where needed. But in most cases, especially for ADW, Autonomous Data Warehouse, you don't need partitions to run quickly. So we want to combine all those partitions into one big partition on import. On the import side, you can have the same effect by saying partition options equals merge, and it will combine any partitions found into the dump file into one big partition. Now, the other reason to group partition table data on export is performance. because once it's in the dump file as one big partition, then when you import, we can invoke the parallel query engine to have multiple PX processes doing that import into one big unpartitioned table. On ATP in particular, that's autonomous transaction processing in particular, we have a much smaller list of objects that we would suggest that you exclude, because often with transaction processing, ATP, you would want those indexes in place, for example, but we still want you to exclude clusters and DB links. DB links are supported in autonomous transaction processing and in ADW, but you want to redefine those once you get to that new environment, because it might be different users in place and might have different privileges. Finally, for compliance purposes in autonomous database, just be aware that we will make sure that all your lobs get converted to secure file lobs. We have the setting for the DB secure file parameter set to always, so that you don't even have to specify the transform that's available. We will just do it automatically. It's really time to move those basic file lobs to secure file lobs for much better performance and scalability. Okay, so that's tips on how to use Data Pump. Now let me turn you over to Mike to give you a couple of other ways that you can actually migrate up into autonomous database.
So you're almost there. Just 2 hints here. One for the Cloud Shell. So it's SQL CL, but in the cloud interface. How do we access it? So I'm in my autonomous compartment. I click in the top menu on Cloud Shell, and then it starts opening and creating the Cloud Shell machine. So I have command line access. In order to connect here, I need the OCID. I copy it, and then in my Cloud Shell, I define some environment variables. The ADB ID, where I use the OCI ID, a wallet name, which is not there yet, but I define it. This is the name I want to create, and my wallet password. And in this case, I ask the autonomous database to generate the wallet with this information. And it generates the wallet, it downloads the file automatically. So with that wallet, I can now connect with SQL CI here. And when I'm connected, I just query, for instance, in my metal schema, the albums table. So very simple, very straightforward, and it allows you even to use export import if you would like to. And just another hint, if you think, okay, now I really want to start that, you can start with the quick start workshop here. So with this link on the slides, it gives you everything, how to query your data, how to visualize your data, and much, much more. All done with very, very nice labs. So that's it from our side regarding autonomous.
Now let's transition from talking about migrating specifically to autonomous database to the other types of database cloud service available in Oracle Cloud. Database cloud service goes by many names: database cloud service, DBaaS, OCI, and even within that, there are multiple kind of flavors of our database cloud service. So let's get into it. First, I'm going to mention the support timeline for cloud releases. You see where we are in almost approaching mid-2021. And you'll notice that this slide was not something that we even had to mention in autonomous database, because in autonomous database, we're going to be moving forward on a regular cadence of upgrade and such that will be kind of happening in the background. For other services, you do have to pay attention to and monitor and manage your use of particular database versions. In where we are right now, especially for 11.204, we're already into the market-driven support period for 11.204. 12.102 is going to end its extended support soon, and so on. But there is this market-driven support for 11.204, but only for Exadata Cloud Customer, Database Cloud Service on OCI, and Exadata Cloud Service. If you want more details here, the cloud support dates are also listed in our release schedule of current database releases. So now let's talk about the different flavors of your database cloud service. The entry level, or the kind of smallest possible entry point is going to be the virtual machine-based service. You would provision this with either grid infrastructure and ASM or local volume management. Local volume management is a lot faster. The restrictions here, there is only one container within a particular database cloud service. So when you provision a database service, you get one and only one container database, and that's the one that's pre-created in that virtual machine. You can manage the PDBs however you want, but there's only that one CDB. You can't upgrade the operating system or grid infrastructure. You can patch them, and the patching is done through the tooling, but you can't upgrade them. And you also can't install an additional Oracle home. The Oracle homes are managed by the cloud backplane. When you create a container database in a database system in the VM service, you'll always get compatible at the default, which can be kind of an issue if you're worried about the ability to downgrade. There is a bit of a workaround here, and the link in the slides where it says unless is a link to one of Daniel's blog posts where he shows you how you can drop the current database and then restore a backup of a different database that has a lower compatible setting. That is okay. That is supported to do. What you can't do is drop the database and then use something like DBCA to recreate it. That is not supported. So follow the blog post if you really want a CDB with a lower compatible than would be the default. The next level up would be your bare metal provisioning. It's kind of what we consider a mid-level service where you're provisioning with grid infrastructure. You can have as many container databases as you want. However, you only get one database per Oracle home. So if you get your bare metal and you want to have multiple container databases there, then you have to install multiple Oracle homes. Again, PDB management, that's all up to you. And again, you cannot upgrade the grid infrastructure or operating system. You will get one data disk group within your grid infrastructure that will hold up to 16 terabytes of data. And then there's Exadata Cloud Service. Exadata Cloud Service is what we would consider the premier cloud service because it has the best database machine out there, which of course is Exadata. And because it's Exadata, it comes with grid infrastructure, which is clusterware and ASM. You can have as many container databases as you want, sharing Oracle homes on that Exadata Cloud Service. Of course, you then also get to and have to manage the PDBs on your Exadata Cloud Service. One of the things that you might want to take advantage of in the database cloud services or DBaaS services is the ability to define a custom image. And this can be helpful if you're managing especially multiple databases in the cloud and you want to do what we would normally recommend, which is to standardize and automate. So the way we can do this is to create a custom image on demand in OCI. And let's look at how to do that. So here's a little video of creating a new custom database software image. You can give it a display name that is meaningful to you. So we're going to call this our gold image for 19.8. We select the database version that we want to use and the patch set update, or in this case, release update 19.8. And if we wanted to, we can even specify some one-off patches that are needed for our environment. That will get sent to the gold image as a service system, and it will create that gold image for you. Now, when you go to create a database system, after you provide the basic names, you can then select a custom database image from your library and say, I want to use the gold image that I defined with the specific one-off patch that I selected, and that's what will be used for your environment. So this can be a very useful tool. It's very similar to what we would ask you to do on premises using something like Fleet Patching and Provisioning or Lifecycle Management Pack. It's built right into the cloud service. Switching gears a little bit, let's talk about scaling in database cloud service. In a typical migration, you're going to need your three sets of resources, your OCPUs, your IO throughput to your storage, and then the network throughput because you're migrating over the network. So that's certainly going to be important. But scaling works differently depending on the flavor of service that you're using. In a virtual machine, you can change the OCPU shape up and down, anywhere from 2 to 24 OCPUs, but the scaling of your CPU happens offline and can take 10 to 15 minutes. Storage can scale online, but it's a one-way trip up. So you never can scale back down to a lower amount of storage used. And remember that storage is network attached. That means every time you are writing to storage, you're using your network throughput. And that means that if you're consuming data from one system and then writing it to storage on your system, you want to double the throughput there because you have the throughput for consuming, for pulling it in, and then throughput over the network for writing to that network attached storage. Now, one of the other things that might not be obvious is that your network throughput scales with the number of OCPUs. And that means that your I/O throughput will scale similarly. So this is measured. You can follow the link to Daniel's blog post where he measured this, but he was looking at the throughput over the network based on your CPU shapes from 1 all the way up to 24 OCPUs. So that's a pretty important stat to have when you're thinking about what your service level agreements, what your performance requirements are. Now, bare metal, a little different. You can scale your OCPU up and down, and it scales online. So you don't have that 10 to 15 minute wait to change your OCPU shape like you would on a VM. Well, why is that? Well, because bare metal, you're on the bare metal, whereas VM scaling up and down might require doing something like relocating a VM to another server that has the CPU capacity. You've got locally attached disks here, not network attached disks, so you don't have to worry about the network throughput for your I/O. And then you've got a 25 gigabit per second network interface. That translates to about 11 terabytes per hour if you're doing the math. So that can be really, really performant for you. And then on Exadata, very similar. The main difference here is now you've got the Exadata storage system instead of just locally attached disk. And that gives you all of the benefits that the Exadata has for smart scans and flash storage and all of that. When you're going to be transferring files up for your migration, it's a really good idea to download and install the OCI command line interface or OCI CLI. It has all that file management that you would need for migrating lots of files or big files over the network. Anytime you're downloading, uploading massive files, of course, over the internet, you would want to use some sort of file manager, FileZilla or something like that. Well, we have it specifically for OCI. The OCI command line interface can handle both multi-part uploads. So if you have a big file, it can break it up automatically for you, and bulk uploads so that if you have many files, we can handle those as one operation and still get the parallelism that you would want. So OCI CLI is a pretty much mandatory download if you want to manage your files effectively when you're migrating up to our cloud service. When it comes to multi-tenant and migration, remember that in 19C, you by default can have 3 user-created pluggable databases without requiring the multi-tenant option. But in high performance or extreme performance, that's what the HP and EP are for Database Cloud Service or any version of Exadata Cloud Service, you can actually have up to 4,096 pluggable databases. If you want to keep within the limit, so just say you're on Database Cloud Service Enterprise Edition, where you don't get more than the 3, set your max PDBs parameter to 3. And that way, if someone tries to create that 4th pluggable database by mistake or just not knowing that you're not licensed for it, it will prevent that from happening. The Database Cloud Service tooling doesn't really care about the PDBs, so you can create them and drop them as you want. What the Database Cloud Service tooling is doing is working at the CDB-wide level. Encryption is something that we have end-to-end in our cloud. We have it in all of our editions. Even in standard edition in the cloud, we have TDE, even though it's not available on standard edition on premises. We use network encryption and disk encryption, all the good stuff. Now, having TDE, it's must-have. And you might want to look at the office hours about encryption, where you get your questions answered. And there is, Daniel has a really good TDE from a non-security guide presentation that he's done that really makes it very understandable for kind of lay people, in as much as any DBA is a lay person. In OCI, you are allowed to use the isolated key store mode, but that is not supported by tooling, so you'd want to use a shared key store if possible. Okay, that's the overview of Database Cloud Service, DBaaS, OCI, whatever you want to call it. Now we can start looking at how to migrate into that and how it might be different in some cases than migrating to autonomous database.
All right, thanks, Roy. Now let's talk about zero downtime migration. To give you a bird's eye perspective, what we do with zero downtime migration is that we first build a copy of your database. We keep the copy of the database in sync until you're ready to perform the final switchover. Depending on which method you use, you can do the migration with zero or at least very little downtime. These are the keywords that define zero downtime migration. The most important one is the last one highlighted in red, free. Zero downtime migration doesn't cost anything. You have to pay for the infrastructure that you provision in OCI, but zero downtime, the tool itself, doesn't cost anything. In addition to that, the functionality that zero downtime migration use, for instance, Data Pump and GoldenGate, is part of CDM. It's part of the free offering. So if you use GoldenGate to migrate your database, you don't need a separate GoldenGate license on your source and target systems. It's included with ZDM. When you migrate your database, you should look at where your source database is. Typically, you have an on-prem database that you would like to migrate into OCI. But you could also use it, for instance, if you have an old OCI C instance that you need to move into the new next-gen OCI. In addition to that, you can use it, for instance, to move a database from a VM into XRCS. That's also possible with ZDM. Supported database releases. We can cover 11.204 and anything newer than that. If you do physical migrations, and I'll touch upon a little later what a physical migration is, you can migrate into the same database release. The target release has to be the same as the source. Whereas when you do logical migrations, you can migrate into a database on the same or higher database release. The source platform has to be Oracle Linux, and the target platform can be autonomous database, either dedicated or share. You can go to some of the database cloud services, VM, bare metal, or XRCS, and we can even cover the Exadata flavors like XRCC or even Exadata on-prem. You can use it to migrate standard edition and enterprise edition databases. There are restrictions with standard edition databases when you have to do zero downtime migration. When you do physical migrations, we'll be using DataGuard as the migration vehicle, but that's not part of the standard edition offering. So if you want to do a zero downtime migration on a standard edition database, you have to use the logical approach, which uses Data Pump and GoldenGate. You cannot migrate between editions. So a standard edition database will be a standard edition database in the cloud. And likewise with enterprise will be an enterprise edition. Non-CDB, CDB doesn't matter. ZDM can do both. If you have a non-CDB database, you can optionally choose to convert it into a PDB after the migration. If you choose that, you should be aware that the PDB migration does incur some downtime, at least when you use the physical migration path. Whereas if you use Data Pump with GoldenGate on top, you can migrate directly into a PDB. When you migrate an entire container database, we will migrate all the PDBs along with it. It's not possible to exclude some of the PDBs. A single instance database will be migrated into a single instance database, or optionally, we can convert it into a proper RAG database. However, if you have a RAG database or a one-node database, we will migrate it into a RAG database in the cloud. The encryption status of your source database doesn't matter. It can be unencrypted, it can be encrypted. No worry, ZDM will cover both. However, the target database is always encrypted. This is one of the key benefits of OCI. You get TDE tablespace encryption as part of your license, and we will ensure that your database, when you migrate it into OCI, will be encrypted from the very first byte. When we transfer the data from your on-prem data center to the cloud, we will ensure that the connection is secured and your data is secured in transit as well. Now let's talk about the two migration methods that you can use with ZDM. First, we have the physical migration, which was part of the original release of ZDM. When you use the online approach, we will build a data guide in OCI, keep the two in sync with redo apply until you optionally do a switch over. For an offline approach, you can do regular backup restore. In contrast to that, with the latest release of ZDM, we now also have the logical migration approach, where you can use a combination of Data Pump and GoldenGate to do a zero downtime migration. Optionally, you can just do a regular Data Pump export import, but that will incur some downtime. When it comes to standard edition, it can use both approaches, online and offline. There is no restrictions with standard edition databases like you see with physical migrations. Now let's talk about how ZDM actually works. And first we're going to look at physical online migrations. In this scenario, your users are connected to the source database, the on-prem database. You provision a new target DB system, a new target database in OCI, and then you download and install ZDM. Here it's depicted as running on-prem, but you might as well install ZDM on a small Linux compute node in OCI. The ZDM service host must have SSH connectivity to both the source and the target database. Once that has happened, ZDM will make a backup of the source database and put it into object storage in OCI. Then it'll instantiate a standby database using that backup, transparently encrypted into your target database. And now it'll keep the target database in sync with the source database by sending redo and applying redo on the target database until you are eventually ready to complete the migration. At your will, simply perform a data guard switchover and your users will now connect to your target database in the cloud. The migration has been completed with very little or no downtime. That was it about physical migrations. Now let's have a look at how logical migrations work. Here it's the same. Your users are connected to the source database and you provision a new database in OCI. It's always encrypted with TDE, hence the little key there. Again, you download and install ZDM. On-prem, in cloud, doesn't matter. But you must ensure that there is SSH connectivity to the source database and SSH or SQLnet connectivity to the target database, depending on whether you are targeting an autonomous database or some of the other database cloud services. Then you provision a GoldenGate image, and ZDM will configure your source database and configure the GoldenGate installation so it will capture all the changes that are made to your source database and put it into trail files. Now it's time to do an export of your source database and we will put the dump file into the object storage. Next, we can use those dump files to import the data into your target database. Once that is completed, ZDM can configure the target database to apply the GoldenGate changes. It can take all the changes from the trail files and keep the target database in constant sync with the source database until you are eventually ready to complete the migration. You then do a switchover. You disconnect the users from your source system and connect them to your target database. And that's it. With a combination of Data Pump and GoldenGate, you can do logical migrations with zero downtime. If you're more interested into this and you want to see the nitty-gritty details, I've included here a link to a blog post series which has a long description of the entire process, how-to, step-by-step troubleshooting, and so forth. And there's even a bonus post on how to use it with XRCS. In addition, we have a dedicated playlist on YouTube that will show you how you can use SetDM.
So on with the next migration method, DataGuard. So in case your current on-prem database is not on Linux yet, there are still combinations allowing you to build up a data guard, a heterogeneous data guard. So in the example here, the database is on a Windows server and the standby will be on Linux. This is the MyOracle support note describing the allowed combinations. So basically for Windows ports, it means you can build up a standby on Linux since 11.107 and for Intel Solaris since 11.2. You can query that information about your operating system in the database here with VDollar transportable platform. So as long as it says little endian format, there's a good chance that you can have a heterogeneous data guard. And you find all the description and how to set it up all step by step in this excellent technical brief, Hybrid Data Guard to Exadata Cloud Services. But even if you don't go to Exadata Cloud Services, it applies to other flavors of the cloud as well.
Transportable table spaces is another method that you might want to use to migrate to the cloud, particularly when you have large databases. No different than how you would want to use it on premises for the same reasons. The other thing about using transportable table spaces is that it can go cross-endian. So let's get back to the basics on this. We'll go over the high level and how to use it to migrate to the cloud. First of all, I mentioned endianness, cross-endian transforms, and this is something we covered during our migration webinar, but we'll go over it again here. Big endian versus little endian is a distinction of the processor and operating system architecture. Simple as that. Where is the high order byte located in the data? Is it conceptually on the left or on the right? When you're migrating from a big endian platform to a little endian platform, we'll need to convert the data files. That's where transportable table spaces and RMAN come in. So the reason we need to do this is that Oracle Cloud is Intel x86 Linux, which means it is a little endian platform. All these other platforms that you see listed here with this query out of the VDollar transportable platform view are big endian. So what's not listed here, things that are little endian in addition to Linux include Windows, include Solaris x86. That means that if you're migrating a big endian platform, such as HPUX or AIX or Spark Solaris, up to Oracle Cloud, you are performing a big endian to little endian conversion. And that means that after you get the data files up to the cloud, you have to convert them somehow. As it says in the pro tip here, by the way, even though we talk a lot about cross-platform transportable table spaces, transportable table spaces can be a very good way to move a database, even if it's on the same platform or same endianness. It's just that we tend to talk about the conversion more because that's where the mechanics come into play. So how do we convert data files cross-platform, cross-endian? There's two ways to do it. One is RMAN. With RMAN, you're performing an out-of-place conversion, which means we create a copy of the data files, and that, of course, means you need twice the disk space. If you've got a 100 gigabyte database and we perform an RMAN convert on the data files, you need 200 gigabytes of disk space available to create those copies. Of course, once you're done with the conversion, you can get rid of them, but remember how I said earlier that storage only scales up in our cloud? That's something that you might want to pay attention to, because if you have to scale up to do the convert, you can't scale back down again. DBMS file transfer is another way to convert data files. If you grab files from one system to another using the DBMS file transfer package, we convert those data files from one platform to another kind of in flight over the wire as we're doing the copy. So that's nice because it means we don't have to have the extra disk space for that conversion. However, DBMS file transfer is not supported in the cross-platform transportable table space Perl scripts that you might use for this process, especially with incremental backups. When we're migrating with transportable table spaces, we have to make the distinction about the two different things that we're going to be bringing along, the metadata and the data. The reason for that is that the metadata, your users, your constraints, your roles and privileges and so on, is stored in your system table spaces. And the system table spaces cannot be transported cross-endian. They can go cross-platform on the same endianness like Windows to Linux, but not cross-endian like AIX to Linux. Your data table spaces, though, those can be converted cross-endian. So all the data in your database, which is generally the bulk of the volume of the database, is stored in your user table spaces and can be converted. So that means the stuff that's in the system table space and the stuff that's in the data table spaces have to be moved differently. The things that are in the system table space would be exported with data pump. That's usually a metadata-only export of your users, grants, roles, privileges, packages, procedures, and all that kind of stuff. The data can be moved by simply copying the data files from one system to another. And then if you're going cross-platform, you have to then run a conversion, either that RMAN convert or use a DBMS file transfer to get it done during the data copy. So in concept, we have our system information that's tied to the database version, whereas your data is independent of database version. You could have your read-only table spaces of data that have been around since 9i and still readable by 19. The system table space information only works in the same database version, whereas the data is upward compatible. And then the system information, your users, roles, grants, privileges, and so on, only work in the same database architecture, by which we mean non-CDB compared to PDB. You can't have the system information from a non-CDB and just kind of copy it into a pluggable database. We have to do the import and hook everything in correctly, whereas your data table spaces from a non-CDB can easily be hooked right into a pluggable database. So data pump is used when you're going across database version, cross-platform, cross-architecture, whereas transportable table spaces, you would just copy the data files. That means that transportable table spaces can work to the same or newer database version. You don't have to be performing an upgrade, but you can as part of the import. You can go from a non-CDB into a pluggable database. You can even go from a pluggable database into a non-CDB. And then knowing that, we can look at how you can move them step by step. And I'll let Daniel take over for this.
All right. Thanks, Roy. Now that we know the basics, let's look at some examples on how you can use transportable table spaces. The first example is to use transportable table spaces together with full transportable export-import. In this example, I have my source database running on-prem as a 12.102 database, and I would like to migrate that into a 19c PDB running in the cloud. So we migrate to a different data center, we migrate to a different architecture and to a different release. But all that is possible with transportable table spaces. In my source database, I have a system table space and a user table space, which I call data. In a normal database, you would have multiple table spaces, undo, sysocs, users, and so forth. But for simplicity, I'm just going to keep it to those two. In my new target PDB, I only have the system table space. It's a completely empty database. Notice the color difference. It's because the two databases are running on a different endian format. First, I set my data table space read-only in my source database. Now I have downtime on my application. The database is still up and running, but since the table space is read-only, it means that we have downtime. I then copy the data files to my target system, and I can then use RMAN to convert the data files from one endian format into the other. But be aware that the conversion happens out of place, so you need additional disk space to hold a copy of the data file while the conversion takes place. When you have converted all the data files, you can use data pump and full transportable export-import to first plug in the new table spaces, and then you can transfer the metadata from the source database into the target database. But be aware that we already have the data, the index structures, all the segments are still there on the target system. We just need to transfer the metadata, which is information about the users, grants, PL-SQLs, sequences, and so forth. So it's really not that much information that we have to transfer. But when we set the tablespace as read-only, it meant that we have downtime on our application. If you have a database, 10, 50, 100 terabytes, it's huge. It's going to take a while to copy all that data to the cloud. So can you make it faster? Yes, we can. Again, with full transportable export-import, transportable tablespaces, and with incremental backups on top, we can do the trick. I have the same example here, 12102 into a 19c PDB in the cloud. We have the same tablespaces, again, difference in endian format. But instead of setting the tablespaces read-only and copying the data files, we're going to first create a level 0 image file backup. When we restore the backup on the target system, we convert it into the new endian format. And again, here, the conversion happens out of place, so you need additional disk space on the target system while we do the conversion. Then you can do an incremental backup to take the latest changes from the source database and apply those on the target database. And you can do another one, and you can do another one. And in fact, the more level 1 incremental backups you perform, the quicker the final incremental backup can complete and the less downtime you need to do the migration. Because now it's time to do the migration. We now set the tablespace read-only. We have downtime on our source system, and we can perform the final incremental backup. Once that has been applied on the target, we can use full transportable export-import again to plug in the tablespace and transfer the metadata. So even for databases that are hundreds of terabytes in size, we can migrate those to the cloud because the downtime we need is only enough time to perform the final incremental backup. And if you have blockchain tracking enabled, that's really fast. Transfer it into the cloud and apply it. But I bet if you have a database of hundreds of terabytes in size, it's probably so important that you also need DataGuard. Once you have completed the migration and the users are then connected to the new target database in OCI, you could start to build a new DataGuard. But it means that your primary database is not protected until the DataGuard is ready. And that can take a while if you have a 100 terabyte size database. What can you do? Well, when you provision the new 19c PDB, the empty PDB, you can then create a DataGuard and set that up already. Then we can ensure that we have the same data files on our source database, on our primary, and on our standby database. And we can then restore the data files on our primary and on our standby database to the exact same CN. This is very important. You have to restore to the exact same SCN. But don't worry, it's not as complicated as it sounds. Use the same backups, apply them to both the level 1 backups on your primary and on your standby database. We can then use data pump to do the full transportable export-import, and the tablespace plugin and the metadata information will then propagate to the standby database via redo apply. So it is possible, even for huge terabyte-sized databases, to be protected by DataGuard from the minute you switch over to the target database in OCI. There is a really good Moz node with step-by-step instructions if this is something that you want to endeavor into. I'll leave it to Mike to cover the rest about transportable tablespaces.
Now, if you would like to transport, there are a few things to take care on, so we have a checklist for you. And at first, we start with the database creation. This is the target database, and as transportable tablespaces and full transportable export-import work same version or to a higher version, compatible must also be same or higher in your new target database. It can be higher. Also, in addition, there are some other requirements where we have workarounds for you. So identical database character set, national character set, time zone, and time zone file version. But what if that is not the case? In OCI, a database gets created by default with AL32 UTF-8. If you would like to change this, you have to go to the Advanced Options screen. Since Oracle Database 12.2, you can mix in an CDB with AL32 UTF-8, PDBs with different character sets. And this is what we will do here when we do transportable table spaces and your source is not AL32 UTF-8 already. So what would be the workaround here? You keep your production CDB with AL32 UTF-8, but then you provision a temporary CDB with your desired character set. In this CDB, you create a new empty PDB, and this one will be the one which receives now all your transport information and your files. And once you are done, you clone this PDB into your AL32 UTF-8 production CDB. Afterwards, if all is done, you can just terminate this intermediate CDB with the PDBs. OCI DB systems are by default in UTC time zone. And again, in the advanced options screen, you can change that. So set the US time zone, and this will affect sys date and sys timestamp. And there's a good MOS note explaining all the aspects. If you would like to change the time zone defaults to UTC, then you change in the CDB with all the database, set time zone, and here you see the time zone. PDBs can have a different one, so they don't have to be aligned all together. Alter pluggable database, PDB, set time zone, and then you define the time zone. Now, from the backup recovery perspective, it's very beneficial if you have block change tracking enabled, which requires Enterprise Edition on-prem and in the cloud, on the cloud side, Enterprise Edition Extreme Performance or Exadata. So this is how you check if you have a blockchain tracking file on. Select status file name from $3 blockchain tracking, and you would change this with Alter database enable blockchain tracking. Then, by default, the conversion on the destination side is faster than on source. So the Perl scripts will do the conversion for you. If you have TDE encryption with transportable table spaces works only for same NDNS migrations, not across NDNS. And the Perl scripts we use almost in all cases, I would say these days, for ARM and incremental backups. Those can be downloaded via this MOS node. Currently, they are version 4 Perl scripts, and the source needs to be a 10.203 or newer when you deal with the Perl scripts. The target, hopefully it's not an 11.204 anymore, it should be 19c, but the lowest target version could be 11.204 if needed. So a few general best practices. Practice, practice, practice. There's no way around that. So start with a small database, often that helps. Don't take your 80 terabyte system for the initial test and prove that the process works fine, and then go forward with the production size database. Automate as much as possible to ensure consistency and avoid any sort of human error. Always save all logs and output from data pump, from Armin, and so on, and have a cleanup procedure. Just for your tests, it makes life so much easier if you can just revert to the before, but also when you're done, that it cleans up everything carefully. Yeah, and then on with Roy with the next technique, which will be data pump and GoldenGate.
While the physical migration methods of DataGuard and Transportable are great for migrating to the cloud, especially for big databases and same platform, there are still going to be times when you want to perform a logical migration, whether it's changing character sets or time zones or some other characteristic of your database, or just to reorganize the data a little bit. So let's talk about data pump migrating to database cloud service. Now, one thing I'm not going to do is repeat everything I already said about migrating to autonomous database. Almost all of that applies except for the ADB compliance slides, where we talk about the specific transforms for the autonomous database environment. You can keep your segment attributes, you can use your directory objects, you can keep your index organized tables if you want to when you move to database cloud service. That's all under your control. One thing that we should mention that's different is secure file lobs, because remember, for autonomous database, we will automatically convert your basic file lobs to secure files because we've set the DB secure file parameter to be always in that environment. When you're moving to database cloud service, it's still a good idea to make that transition. And for that, you would specify the transform lob_storage to secure file as part of your data pump import. Now, you've heard us say this since 11.1, that you should be moving from basic file lobs to secure file lobs. If you'd like a good example of why, we can look at how long it takes to import the same table with a lob column in it versus with basic files as opposed to secure files. And you can see why this is happening. With the basic file lob, because we are not allowed to do parallel IO into a table with a lob column, we have to import with one direct path thread. So that is 804 seconds using the direct path load. With secure file lobs, however, for this large table, which is 31 gig, that's pretty large, we can use external tables parallelism to load that table in parallel and load it about 3 to 4 times faster than we could with direct path. That's the kind of performance boost that you will often see with secure file lobs over basic file lobs. And it's not just about migration, it's about day-to-day operations as well. So it's really to your benefit to migrate to secure files when you're going to the cloud, or indeed, anytime you're using data pump as part of your migration. Now, it used to be that we would recommend using move to OCI to migrate to our database cloud service. And many of our customers may know this note, move to OCI, moving data to the Oracle Cloud Database in quote unquote, one click. Now, with ZDM finally being released, especially with the logical migration, you'll find in that note, there is a specific section that says that move to OCI is actually now included in ZDM. So if you've been using Move to OCI up to this point, what you should really do is go download ZDM instead, because it has all of the Move to OCI functionality for physical migration, plus it incorporates the data pump logical migration. So whether you're going to autonomous database, database cloud service, ZDM is the tool that you want to use. And one of the benefits of ZDM is that it will automatically set up data pump for you and use all of those best practices that we recommended to you. Diagnostics like metrics equals yes and log time equal all. It'll implement compression and encryption for you using the right algorithms. And a real bonus is that when you use compression and encryption as part of ZDM, you don't have to pay for it separately. So even if you're not licensed for the compression option or the security option on premises, ZDM can make use of that because this is Oracle supplied tooling, and we are choosing to use compression, encryption to make your migration as fast and secure as possible. And the same goes for GoldenGate. If you want to use GoldenGate as part of a migration with Data Pump, just use ZDM. It will set up GoldenGate for you. And because it is being used as part of zero downtime migration, again, you don't need an on-premises license for GoldenGate for that migration. So there are so many benefits to using ZDM. It's one tool that can handle your migrations for physical and logical migrations. It can set things up optimally for you, and it can make use of technologies and options that you might not be licensed for, and you won't have to pay extra for them. So that was a quick overview of using Data Pump for your migration to Database Cloud Service, and hard to believe, but we're now at the end of our virtual classroom series. So let me hand you over to the maestro, and Mike, why don't you bring us home?
Finally, it's time to wrap up. Again, we can repeat this over and over again. Keep it simple. For a simple migration, start with Data Pump or whatever we showed you today. If it gets more towards less downtime, SLAs, then the more complex solutions come in, like transportable table spaces, full transportable export, import, and so on. But try to keep things simple. Then watch the recording and get the slides on the upgrade blog. So you can scan the QR code here with your cell phones if you haven't taken note of the upgrade block yet. And we will put up the recording as soon as possible. And then the series is over, but in the EMEA series, which ran in parallel, we have our 9th seminar coming up on May 19, which is performance testing, using the Oracle Cloud for upgrades and migrations. So regardless if you migrate to the cloud, or if you would like to just use test resources and evaluate performance, ensure performance stability by using cloud resources, even if you plan to stay on premises forever, this is the seminar you may subscribe to. Unfortunately, for people in the US or in Canada, it's in a very inconvenient timing, but we will put up the recording shortly after May 19th as well to the upgrade block. So I think it's time to say goodbye.
So that's it for today. Thanks for attending today's session and for attending the rest of our series. We hope that this has been valuable input for you in your next database migration or upgrade.
So far, this was our last virtual classroom. But remember that all the previous classrooms were recorded so you can watch them again and again and again.
Hey, and also visit our YouTube channel. We have a lot of cool videos there, not only regarding migrations, but also for upgrades with DataGuard, multi-tenant, cool features, and much, much more. So we hope to see you soon. Until then, take care, stay safe, and thanks for participating. Happy migrations. Thanks, and bye-bye.